Welcome to Quick Course Digest. Today, we're jumping right into our summary of Introduction to Nutrition. We're going to break down what's actually in our food, how our bodies work their magic to turn it into power, and, what all of this means for our health in the real world. Let's get into it. All right, here's our game plan. First, we'll look at the fuel itself, carbs, fats, and proteins. Then we'll see how that fuel becomes energy. After that, we're going to zoom out and look at the whole energy balance thing. We'll meet the body's support crew, and finally, we'll figure out how to make sense of all this in the modern world. So, first up, the fuel. Look, at the heart of literally everything you eat are these three mini players: carbohydrates, fats, and proteins. These are the fundamental building blocks our bodies run on. Period. It sounds like a super simple question, right? But it's actually worth taking a second to think about. Before we dive into all the science, what is food? At its core, it's really just a package of chemical energy and all the raw materials our bodies need to function, to grow, and to repair themselves day in and day out. I love this slide because it just lays it all out so clearly. Think of it like this. Carbs are your go-to quick access fuel. Fats, they're your dense, long-term energy reserves. But they're also super important for building cells. And proteins, well, proteins are the actual construction crew, building and repairing just about everything in your body. So what even is a complex carb? It's just a fancy word, polysaccharide, for a long, long chain of simple sugars all linked together. Plants store their energy this way, as starch. So when you eat potatoes or bread, your body gets to work, breaking those chains back down to get at the energy inside. And on the flip side, this is how our bodies store fat for the long haul. A triglyceride is basically the neat little package our body uses for energy storage. So when you hear people talk about body fat, this molecule is what they're actually talking about. It's a super efficient way to pack a ton of energy away for later. Okay, so we know what the fuel is, but how does your body actually turn, say, a piece of pizza into cellular power? That whole process is an absolutely incredible transformation engine, and that's what we're looking at next. This whole journey kicks off the second you take a bite. Your mouth starts breaking down carbs right away with an enzyme called amylase. Then your stomach, with its high-acid environment, gets to work on proteins using pepsin. But the real magic, that happens in the small intestine. That's where everything gets fully broken down and absorbed. And finally, the large intestine does the cleanup, reabsorbing water and getting the waste ready to go. And all of that digestive work, all of that breaking down, it's all for this one thing: ATP, or adenosine triphosphate. This is the goal. Seriously, you can think of it as the universal energy currency for every single cell in your body. The entire point of metabolism is to turn your food into these tiny little molecular batteries that power everything we do. Metabolism is really a two-way street. On one side, you've got catabolism, that's breaking things down to release energy. It's like demolishing a building to get the raw materials. On the other side, you've got anabolism, which uses that energy to build things back up, like constructing a brand new building. It's just this constant cycle of demolition and construction. Now, when it comes to getting energy from carbs, everything starts with glycolysis. This is the first absolutely critical step where a glucose molecule gets split in two. What's cool is it's fast, it doesn't need oxygen, and it gives a quick burst of ATP. It basically kicks off the entire energy production line. Okay, let's pull back from the tiny cellular level and look at the big picture: energy balance. This is where we start to connect all that biochemistry to things like weight management and our daily energy needs. The calories in, calories out idea. I bet you've seen this number before. It's the classic rule of thumb that a surplus or a deficit of about 3,500 calories equals 1 pound of body fat. So the theory goes, if you create a 500-calorie deficit every day, you'll lose a pound in a week. Simple, right? Well, here's the thing. It's not nearly that simple. The human body is this dynamic, adaptive system. It's not a simple calculator. When you cut calories, your body can adapt by slowing down its metabolism, which is why people hit weight loss plateaus. Plus, everyone's body composition, hormones, and even sleep quality play a huge role. So, that rule is a decent starting point, but it is far from the whole story. Now this is fascinating. It shows where our calories are actually going all day. And check this out. The vast majority, we're talking up to 75%, is just used to keep the lights on. That's your basal metabolic rate. That's just your body existing. Physical activity, it's a much smaller piece of the pie. And get this, about 10% of your energy is spent just digesting the food you ate. Okay, moving on. If carbs, fats, and proteins are the fuel for the engine, then you can think of vitamins, minerals, and your gut health as the essential support crew. They're the mechanics and the engineers, making sure the whole system runs like it's supposed to. So, what's the difference between vitamins and minerals? Here's a really simple way to think about it. Vitamins are organic. That means they're made by plants or animals. Minerals are inorganic. They come straight from the earth through soil and water. But both are absolutely essential for everything from building strong bones to producing energy. And we absolutely cannot forget the trillions of tiny microbes living in our gut. It's a whole ecosystem in there. We can support them with probiotics, those are the good bacteria themselves, and with prebiotics, which are basically the food for those good bacteria. And a combination of the two, called symbiotics, can have an even more powerful effect. All right, for our last section, let's bring it all home. How do we take all this knowledge and actually apply it in the real world? Especially when we're just constantly bombarded with marketing claims and so much confusing information. This is a really, really important question. A lot of us just assume that supplements are regulated the same way as prescription drugs. But the reality, well, it's very different. And understanding this is key to being a smart consumer. The answer goes back to a 1994 law called DSHEA. And it basically defines supplements as a category of food, not drugs. Now here is the crucial takeaway. This means manufacturers do not have to prove their products are safe or effective before they hit the shelves. The FDA can really only step in after a product is already on the market and has been shown to cause harm. So if we put all the pieces together, what does a truly successful approach to weight management look like? Well, it looks like this. It's not about some quick fix. It's about building sustainable habits, setting realistic goals, and having a long-term plan. And notice how it includes things like sleep and stress. That just reinforces that our health is a whole system, not just a number on a scale. We have covered a ton of ground here, from macronutrients and ATP all the way to energy balance and supplement regulation. So I'll just leave you with this question to chew on. Now that you have this foundational knowledge, what is one small, informed change you can make, maybe even today, to better support your body's incredible systems?